All right, today we are jumping right into a mathematical mystery. We're going to play detective and uncover a really clever shortcut that solves a huge problem in just a few simple steps. So, let's open up the case file.
Here it is, case number 667. The question seems simple enough, right? Is this number prime? And just as a quick reminder, that means it can only be divided by 1 and itself. Our mission is to figure out if 667 is hiding any other factors.
Now, the most obvious way to do this is just brute force. You could try dividing 667 by 2, then 3, then 4, all the way up to 666. But come on, that's not detective work, that's just busy work. There has to be a smarter way to crack this.
And of course there is. Math is just full of these elegant, beautiful solutions, and this is a perfect example. So let's look at the shortcut that's going to slash the number of suspects we need to investigate. Our first and honestly our most important clue for this entire investigation is the square root. I know, it might seem kind of random at first, but the square root of our number, 667, is the secret dividing line that's going to break this whole case wide open. Okay, so here's the crucial idea. Think about how factors actually work. If our number, 667, has a factor that is larger than its own square root,
Then it absolutely must have a partner that is smaller than the square root. I mean, think about it. If you multiply two numbers that were both bigger than the square root, the result would be way too big. So factors always come in pairs, one on each side of that square root line.
This whole concept is what we call a factor pair. Take the number 8, for example. Its square root is around 2.8. The factor pair is 2 and 4. You see, one is smaller than the square root, the other is larger. So if we can just find the smaller factor, we automatically find the bigger one. And this is the magic part. If we check all the numbers up to the square root and find nothing, well, then there can't be any factors above it either. We're done.
All right, now that we have our main clue, let's actually apply it to our case. It is time to start the real investigation into number 667.
First things first, we need to find that critical dividing line we've been talking about. So, step 1 is to just punch it into a calculator and find the square root of 667.
And there we go. The square root of 667 is roughly 25.8. So what does this actually tell us? It tells us we only need to check for factors up to the whole number 25. If we don't find a factor by the time we hit 25, we're not going to find one, period.
I mean, just stop and look at how powerful that one single insight is. We've gone from checking 665 potential factors all the way down to just 24. We've eliminated over 96% of the work with just one clue. But we're not done. We can be even smarter.
Our suspect list of 24 is already pretty good, but believe it or not, we can shrink it even more. We don't actually have to check every single number between 2 and 25. We only have to check a very special kind of number.
That's right, we only need to check the prime numbers in that range. Why? Well, think it through. If 667 was divisible by, say, 9, we would have already caught it because it would have to be divisible by 3. If it was divisible by 14, we'd find that out when we check 2 and 7. See, every non-prime number is just made up of smaller prime factors. So if we just check the primes, we're automatically covering all of our bases.
And this is our final list of suspects. Just 8 numbers. We went from 665 possibilities all the way down to these 8 prime witnesses. That is the real power of mathematical thinking.
So, the stage is set. Our list of suspects is incredibly short. It's time for the final interrogation. We're going to test each of these primes against 667 and see if we can get a confession or, a clean division. Okay, the first 3, we can clear them in seconds. 667 doesn't end in an even number, so 2 is out. The sum of the digits, 6 plus 6 plus 7, is 19. That's not divisible by 3, so 3's out. And it doesn't end in a 0 or a 5, so 5 is out too. Boom, 3 suspects cleared.
So we keep going down our list. We test 7, nope, leaves a remainder. We try 11, nothing. 13, 17, they're all dead ends. And you start to get this feeling, right? You start to think, hey, maybe 667 really is prime after all. But there is one suspect left to question.
This is it.
The last test. Everything comes down to this single moment. Does 23 divide evenly into 667?
Yes. Yes, it does. 667 divided by 23 is exactly 29. A perfect, clean division. Our final suspect confessed, and he gave up its partner.
And with that, this case is officially closed. 667 is not a prime number. It is the product of 23 and 29. We found the factor pair, and we did it by checking just 8 numbers. Incredible. Okay, so we've solved the mystery. Now, let's take everything we just learned and package it into a simple toolkit that you can use for any number you come across. This is the whole method right here. First, you find the square root to set your limit. Second, you only test the prime numbers below that limit. And third, if none of those primes divide in evenly, you know for a fact that your number is prime. It's a really powerful and efficient detective's toolkit for your brain.
You know, this case really shows off the beauty of mathematics. It's not about grinding through boring calculations. It's about finding these clever, elegant patterns that solve really complex problems. And it makes you wonder, doesn't it? What other amazing shortcuts like this are just hiding out there in plain sight? Thanks for joining this explainer.